Welcome to the video lecture. In this video, we are going to see about CART algorithm. CART algorithm is nothing but classification and regression trees, and it is a variation of a decision tree algorithm, and it is used for handling both classification and regression tasks. So in classification trees, we are going to determine which class the target variable is most likely to fall, and for regression trees, it is used to predict a continuous variable's value. So decision tree consists of nodes, as you all know. So nodes, the root node is split into sub-nodes based on a threshold value of an attribute. The root node is taken as a training set and is split into two by considering their best attribute and threshold value. The subsets are further splitted using the same logic, and this continues till the last subset we have to find. That is the maximum number of possible leaves in the growing tree. So in this video, we are going to construct a decision tree using CART algorithm to classify whether the given data belongs to particular class. So here, these are the parameters present in your database: outlook, temperature, humidity, windy. These are the parameters, attributes. Likewise, we can say we can give any name to these. These are the columns which these attributes represents the columns, and this is your target column. This data set basically represent whether a person can play or not under the given parameters. So S represents the person can play, and no represents the person cannot play for the given parameter. So for this data set, we are going to construct a decision tree, and the first step in constructing a decision tree is finding the root node of the decision tree. So to find the root node, we have to find the error value for each of the attribute present in the given data set. So to find the error, we have to follow some logic. So I'm going to explain the logic here. So first, let us start with the first attribute, outlook. Considering the attribute outlook, there are three values present in outlook: sunny, overcast, and rainy. There are 5 sunny and other values are overcast and rainy. So out of these 5, the target value is, there are 3 no and 2 yes. So out of total 5 sunny, there are 2 yes and 3 no. Likewise, you have to calculate for overcast and rainy present in the data present in the outlook attribute. So for overcast, there are 4 values of overcast present in outlook, and out of 4, there are 4 yes and 0 no. And out of 5 rainy, there are 3 yes and 2 no's. So from these data values we have calculated, we have to find the error value by constructing a table. That is, for the attribute outlook, there are 3 values: sunny, overcast, and rainy. So the error value can be calculated in such a way that we have to set a rule. The rule has to be set like, we have to set a rule which will produce a minimal amount of error. That is, if I am choosing sunny tends to S, then it will result in 3 error out of 5. So your error value should be minimal. So I have to choose sunny tends to no, which results in 2 error out of 5. So you have to choose the maximum value present in the target column. So I have to set the rule as sunny tends to no, which results in 2 error out of 5, and overcast tends to yes, which results in 0 error out of 4, and rainy tends to S, which results in 2 errors out of 5. So these are the errors calculated for the separate data values present in the attribute, and we have to calculate the total error value for the attribute outlook. So by adding the numerator and the denominator, we can get the total error value for the attribute outlook. So 2 plus 0 plus 2 is equal to 4, and 5 plus 4 plus 5 is equal to 14. So out of 14 entries, we will have 4 as error while choosing outlook attribute as a root node. Likewise, we have to calculate these error value for temperature, humidity, and windy. So for temperature, there are 3 values: hot, mild and cool. So out of 4 hot, there are 2 yes and 2 no, and out of 6 mild, there are 4 yes and 2 no, and out of 4 cool, there are 3 yes and 1 no. So from these data values, we have to calculate the error value. So hot temperature attribute is temperature, and the rules are set as we have discussed before. For hot tends to S. So here we are having equal values for S and no. If it is having equal value, we can set the rule as like anything, that is hot tends to S or hot tends to no. Both of them results in the same equal number of error values. So hot tends to S, which results in 2 error value out of 4, and mild tends to 4, which results in 2 error value out of 6, and cool tends to S, which results in 1 error value out of 4. So these are the error values, and by adding the values we get 5 error values out of 14 entries. So for humidity, there are 2 values, high and normal. Out of 7 high, there are 3 yes and 4 no, and out of 7 normal, there are 6 yes and 1 no. So high tends to no, which results in 3 errors out of 7, and normal tends to S, which results in 1 error out of 7. So your total error while choosing for the attribute humidity is 4 error out of 14. So for windy, there are 2 values, true and false. Out of 6 true, there are 3 yes and 3 no, and out of 8 false, there are 6 yes and 2 no's. So based on these values, the error values calculated here, and the total error value is 5 by 14. So we have calculated the error value for the 4 attributes present in the given data set: outlook, temperature, humidity and windy. We have to choose an attribute as a root node which is having minimal error value. So here the attribute having minimal error values are outlook and humidity. Both the attributes are having minimal error value. So if more than one attribute is having minimal error value, then we have to look into the data value present in each attribute. If any of the error value present in any of the attribute is 0, having 0 error. So here while looking to the data value present in Outlook, here overcast is having 0 value, but in humidity there are no 0 values. So hence we are going to choose Outlook as our root node. So your decision tree will look like this. So you have to choose your root node as Outlook, and Outlook is having 3 values: sunny, overcast and rainy. So if Outlook is overcast, then there are 0 error values, then it is directly denotes yes. So your decision tree will look like this. So if Outlook is overcast, we can move on to the target variable as yes. So it means that if your Outlook is overcast, then the person can definitely play. But if it is sunny and rainy, both are having some minimal amount of errors. So we have to find the subset for sunny and rainy value of the attribute Outlook. So the subset can be calculated from your data set. So here skip the Outlook attribute, and then you have to consider all other attributes present in the data set to decide your target column. So if the Outlook is sunny, select the rows which is having the value of Outlook as sunny. That denotes your subset while the value of Outlook is sunny. So if it is sunny, you have to choose the subset from the given data set for the values of sunny present in the data set, and you have to skip the column Outlook, skip the attribute Outlook, and the rest of the attributes will be in your subset. So for rainy, in the same way, from the given data set, for the values rainy present in the Outlook, choose the all other attributes present in your data set and form the subset here. So these two are the subsets formed for the values of Outlook. So Outlook is sunny, which represents this subset, and Outlook is rainy gives this subset from your original data set. So for these subset, we have to find the next decision node and the leaf node using the same logic we have followed for finding the root node. So your next step is finding the decision node and leaf node for the subset for Sunny. So this is a subset we have calculated for Sunny, and for this subset the same logic is applied here to find the next decision node. That is, for each attribute we have to calculate the total error. So there are three attributes: temperature, humidity and windy. And for temperature there are three values: hot, mild and cool. And if there are two values of hot which tends to no. So hot tends to no, which results in 0 errors, and mild, one value yes and one value no. So out of 2 there are 1 error, and for cool there is 0. There will be 0 error out of 1 entry. Likewise, for humidity there are two values, high and normal. If the humidity is high, then it tends to no, which results in 0 error, and the humidity is normal, it tends to S, which also results in 0 error. Likewise, for windy there are two values, true and false. If it is true, then there is 1 error out of 2 entries, and if it is false, then there is 1 error out of 3 entries. So the total error for these three attributes have been already calculated, and we have to choose the attribute having minimal amount of error. Here humidity is having 0 error, so the next decision node will be humidity. So yeah, decision tree will be look like this. For Sunny, the next decision node is humidity, and for humidity there are two values which are having 0 error. So if it is high, it directly represents no, and if it is normal, it directly represents S. So your decision tree will be look like this. So here we can decide, we can come into a conclusion that if your outlook is sunny and the humidity is normal, we can definitely play. If your humidity is high, we cannot play. And if the outlook is overcast, we can definitely play. So for the remaining subset, while choosing outlook is rainy, we have to calculate the next decision node. So this is the subset for rainy, and these are the error values we have calculated using the same logic as we have calculated before. So here windy is the attribute having 0 error. So the next decision node will be windy, and for both the values of windy there are 0 errors. So if it is true, it directly denotes no, and if it is false, it directly denotes S. So your decision tree will be look like this. So for rainy, the next decision node is windy, and if it is true, then it tends to no, and if it is false, it tends to S. So this is the decision tree we have constructed for the given data set. So based on this decision tree, we can decide the target column. We can predict the target column or classify the target column based on the decision tree constructed for the given data set. So the question asked in your data set, in your given problem is, for the given parameters, what will be your target column? So from the given value, outlook is sunny. If your outlook is sunny and if the humidity is normal, then the target column value is S. So this is the value we have predicted for the given question using the decision tree we have constructed for classifying the given data. So this is a decision tree we have constructed for classification problem which is based on CART algorithm. That's all. Thank you for watching the video.